Images are used to approximate geometry in interactive rendering. Here the reflected teapot is approximated with a conventional depth image. However, the depth image does not capture all samples needed by the reflection, which creates artifacts. We propose to use scene approximations constructed with non-pinhole cameras that gather most samples needed. Here the non-pinhole depth image captures the lid and bottom of the teapot and produces a quality reflection. We show that non-pinhole approximations can be used efficiently and effectively in the context of reflections, refractions, relief texture mapping, and ambient occlusion. Conventional depth images accelerate reflections by reducing the intersection of a reflected ray with geometry to a one-dimensional search. An occlusion camera depth image provides a better approximation of reflected geometry while the intersection remains one-dimensional. Our method does not require any pre-computation, so it supports dynamic reflectors and dynamic reflected objects. Here the complex normals of the bunny surface create multiple reflections which are implicitly handled by our method. Higher order reflections are possible by storing normals per pixel in the depth image. A similar occlusion camera depth image can also be used to render refractions. Whereas the occlusion camera provides powerful approximations of a single object, we construct environment approximations using a graph camera. Here a graph camera depth image is used to render reflections on the teapot as it moves through the maze. The literal malleability of graph camera arrays allows sampling distant regions of the maze, including the red bunny in the corner. Conventional relief texture mapping samples poorly along the normal of the surface. Here the brown surface is texture mapped with cone-shaped relief. Notice how the sampling rate degrades as the base shrinks. Once the base becomes smaller than the top, the sides are not sampled at all. We propose to use a single-layer non-pinhole relief texture acquired with an occlusion camera that overcomes the limitation of orthographic sampling. In this example, an occlusion relief texture captures the sides of the barrel well. Like in the case of conventional relief texture mapping, the added surface relief correctly casts and receives shadows. Here an occlusion relief texture captures an entire car. Cars of different color can be easily obtained by using a single occlusion relief texture and altering body color during rendering. One approach for rendering with ambient occlusion at interactive rates is to use the output Z-buffer to approximate the exposure of an output pixel to the environment. However, this can lead to an unstable ambient occlusion approximation as parts of the scene appear and disappear in the output image. We propose to use a non-pinhole Z-buffer that captures most samples needed for the ambient occlusion of the output image pixels. Here a graph camera Z-buffer alleviates the unstable ambient occlusion artifact. The Z-buffers are visualized with color for illustration purposes. Our work argues for the practicality and benefits of abandoning the pinhole constraint. Non-pinhole camera models can be designed to optimally serve the application and dataset at hand with powerful yet inexpensive approximations.